We shall recall briefly what is done in the previous class. So we are discussing about matrices in the chapter 3. So we are discussing about order of the matrix, type. First of all, again we will recall what is a matrix. Matrix is nothing but rectangular arrangement of numbers or functions. Next, order. So order means here we are specifying rows and columns, number of rows and number of columns. Next, type of the matrices. We have seen different types such as row matrix, column matrix, null matrix. Just briefly recall. So row matrix means a single row. For example, A equal to 1, 2. Only one row is there. One row. So it's a row matrix. Single A row matrix. Similarly, column matrix. So if we call B equal to 2, 5, 6. This is a column matrix. Here observe A is of order 1 cross 2. Yes, 1 by 2 or 1 cross 2. Here B is of order 3 cross 1. 3 rows, 1 column. Null matrix. Name itself suggests, and we denote the null matrix as row. So 0 or row. This is right. Null matrix means name itself 0. All the elements are zeros. For example, 0, 0, 0. So it is a null matrix. It is of order 2 by 2. It can be of order 2 by 3, anything. 3 by 2, anything. So this is of order 2 by 3. So this is about null matrix. Next, square matrices. Before square matrices, rectangular matrix. Rectangular matrices. Rectangular matrices where number of rows not equal to number of columns. Again, for example, these are all rectangular matrices. This is one more rectangular matrix. Order is like such that rows, number of rows is not equal to number of columns. Next, square matrices. Square, the name itself suggests. Square means all have same side. So here rows equal, number of rows equal to number of columns. One example, this one. This is square matrix of order 2. Or you can say 2 by 2 or order 2 also, enough. Because square matrix means number of columns equal to number of rows. I will give one more example. 1, 2, 3, 4, 5, 6, 7, 8, 9, any number will do. Positive, negative or 0. This is again, this is a square matrix of order 3 or 3 by 3. 3 rows, 3 columns. Next, I will give one more example. Say 1, 2, 3, 4. This element, 1 and 4, these are called diagonal elements, and this is called diagonal, leading diagonal or mean diagonal. There are different names. Principal diagonal. So these are the from top left to bottom corner. This line. So these are leading diagonal. These are diagonal elements. 1 and 4 are diagonal elements. Now this is a square matrix. Now what is a diagonal matrix? Next definition is diagonal matrix means it's a square matrix whose non-diagonal elements are zeros. So if I write B equal to 1, 0, 0, 2. This is a diagonal matrix. Condition is non-diagonal elements. See, this is a non-diagonal element, this is a non-diagonal element. But these are diagonal elements. Diagonal elements may or may not be 0, but non-diagonal elements should be 0. That means diagonal matrix. Next, scalar matrix. What is a scalar matrix? It is a diagonal matrix, but the condition is the diagonal elements should be same. So one more example. C equal to C 2 2 0 0. This is a scalar matrix where the diagonal elements are here 2 and 2. Both are equal. So that is scalar matrix. Next, unit matrix or identity matrix. Unit or identity. Unit 1. Unit is 1. So how it is? This is like this. So here it is a scalar matrix, but with additional conditions, the elements are 1 only. The diagonal elements are 1 only. So 1 0 0 1 is a unit matrix of order 2. You can have 3 by 3 order also, any order. So this is an example for identity matrix or unit matrix. Next, equality of matrices. Equality of matrices. So when you say two matrices are equal, the two matrices A and B are equal if they have the same order, conditions, same order, and corresponding elements also should be same. Corresponding elements should match. I mean, should be same. One example: A equal to 1 2 3 4, B equal to, again I write 1 2 3 4. So observe here, both are of order 2 by 2. Both are of order 2 cross 2. 2 rows, 2 columns. What about the corresponding elements? Same, 1 and 1. These are corresponding elements. 2 and 2, 3 and 3, 4 and 4. Corresponding elements means elements are from the same column and same row. Same row and same column. First row, first column. First row, second column. Same. Second row, first column. Same. Like that. Corresponding elements. I will give one more example just to make better understanding. So I will write 1x 3 4. Okay. This is variable x. Now I can say A equal to C. When A will be C? A equal to C if x value equal to, observe, 2. Because other elements match, 1 and 1 match, 3 and 3 match, 4 and 4 match, corresponding elements match. Order is also 2 by 2. So when A will be C, when A equal to C if x value is equal to 2. So that is about equality of matrices. Next, equality over. Next, operation on matrices. Operation on matrices. Operations include like addition. There are many operations: addition, subtraction, scalar multiplication, transpose. There are many. We will just, for the time being, we will discuss 3. Operation on matrices. Operation on matrices: addition, subtraction, scalar multiplication. So addition. When addition is possible. Addition is possible. Again, same condition. You can add if the order is same. Order should be same. Similarly for subtraction also, order should be same. You can add A and B provided A and B should have both same order. For example, if A is 2 by 2, B is also should be 2 by 2. If A is 3 by 2, B also should be 3 by 2. Then only you can do the operations addition and subtraction. Otherwise you can't. So it should be same order. Then how the addition is done? Additions are done like this. That is, corresponding elements are added. One example I will give you. A equal to 1 2 3 4 So what is A plus B? What is A plus B? I will call the resultant matrix as C. It is also a matrix. Corresponding element are added 1 and 5. 1 plus 5. So 1 plus 5 is 6. 2 plus 6, 8. Next 3 plus 7, 10. 4 plus 8, 12. So this is A plus B equal to C. What about subtraction? You can do A minus B or B minus A. Either way you can do A minus B. What is A minus B? If I call it as D, the matrix has some other matrix is D. So what is A minus B? A minus B means 1 minus 5, 2 minus 6. So 3 minus 7, 4 minus 8. All will be minus 4. In this case, minus 4. So this is A minus B. 1 minus 5, 2 minus 6, 3 minus 7, 4 minus 6, all minus 4. So this is addition and subtraction. So what is scalar multiplication? Next. Scalar multiplication means multiplying the matrix by a constant. Scalar constant. Say K. So K into K. How it is? That means every element of the matrix will be multiplied by the scalar K. Every element of the matrix will be multiplied by the scalar K. One example. 2A. Suppose A is okay 1, 2, 3, 4. Previous example also I will consider. Any example will do for that matter. What is 2A then? 2A is 2 into this much 1, 2, 3, 4. How it is done? Multiply. 2 into 1, 2. So 2, 4, 6, 8. So 2 into 1, 2, 2 into 2, 4, 2 into 3, 6, 2 into 4, 8. So this is scalar multiplication. Each and every element is multiplied by the scalar. So that is scalar. Then some properties of these addition or operations like addition, simple properties, for addition, commutative property, some properties. Addition. So A plus B equal to B plus A. What is this property? It is called commutative property. A plus, this is commutative. A plus B plus C equal to A plus B plus C. This is called associative. Associative property. Next, K into A plus B. So this is, like K is a scalar, is Ka plus Kb. K is a scalar. Distributive property. K is of course scalar. Next one more is there. A plus 0 is 0 plus A equal to A. What is this 0? The 0 means here matrix 0 matrix of the same order as A. A plus 0 equal to 0 plus A equal to A. 0 is called the additive identity under addition. Identity under addition. 0 is identity under addition. A plus 0 is 0 plus A equal to A. You work out some simple problems. So first question. If a matrix has 24 elements, if a matrix has 24 elements, the matrix has 24 elements, what are the possible orders it can have? What are the possible orders can have? If a matrix has 24 elements, what are the possible orders it can have? Continuation. What if it has 13 elements? What if it has 13 elements? 13 elements. So what is the answer? The answer is like this. Now you have to observe that if a matrix has m rows and n columns, then it will have m into n elements. We have observed already. 2 rows, 3 columns. So there will be 6 elements. 3 rows, 3 columns. There will be 9 elements. So what is given here is it has 24 elements. Total number of elements is, that is m into n. Number of rows into number of columns is 24. What we will do is, we should get pairs such that product is 24. So what are the possibilities? So different possibilities for 24, starting with 1 is 1 and 24. So it can have, what are the possible orders it can have? 1 and 24, because 1 into 24 is 24. So that is 1 row, 24 columns. Same way, you can reverse also, 24, 1. That is 24 rows, 1 column. Because there are product is 24. Next one, starting with 2. So if you start with 2, so 2 into 12 is 24. Same way, 12 into 2 is 24. 2 into 12 is 24. 12 into 2 is 24. This represents number of rows, number of columns. Number of rows, number of columns. Then we can start with a 3. So 3 into 8, product should be 24. Same way, 8 into 3. Next we can start with 4 and is 4. So 4 into 6, 24. Same way you can have 6 into 4. 5 not possible, you won't get 24. 6 already over, 4, 6, 6, 4 over. 7 not possible. 8 already over, 8, 3, 3, 8. 9 not possible, 10 not possible, 11 not possible, because product should be 24. The other possibility is 12 and 2 or 2 and 12. So actually these are the different orders it can have. What are the possible orders it can have? It can have orders like this: 1, 24, 24, 1, 2, 12, 12, 2, 12, 2 already over, sorry, no need to repeat. Okay, 12, 2 already over here. 3, 8, 8, 3, 4, 6, 6, 4. These are the possible orders you can have. What if it has 13 elements? So it is understood 13 has no divisors other than 1 and itself, 13. So it is a prime number. So for the second part, answer is, so if it has 13 means only possible orders are 13, 1, 1, 13. So this is the answer for second part question. If it has 13 elements, it can have 13, 1 and 1, 13. So 2 order. This is for 13 elements. This is for 24 elements. So order it can have for 24 elements are like this. For 13 elements, these are the possible orders. Next question is, construct a 2 cross 2 matrix. Second problem. Construct a 2 cross 2 matrix. Second question, construct a 2 cross 2 matrix. equal to Aij, A equal to Aij, whose elements are given by first question 1 Aij equal to first part under this 1 Aij equal to I plus j whole square divided by 2. Second one Aij equal to I by j. Third one Aij equal to I by j. Third one I plus 2j whole square by 2. Third one I plus 2j whole square by 2. Here construct a 2 cross 2 matrix A equal to Aij. So I means here stands for row, J stands for column number, I stands for row number, J stands for column number. So construct a 2 cross 2 matrix. So there will be 2 cross means 4 elements. So we can take the matrix A as first answer for the first one. Let A equal to, just for representation I will write A11, A12, A21, A22. I call it as 1. A is A11 because Aij. A11, A12, A22. Sorry, A21, A22. A21, A22. A11, A12, A21, A22. This is A equal to Aij. It's a 2 cross 2 matrix. 2 rows, 2 columns. Now we have to fill the elements. So what is A11? A11 by definition equal to, for the first problem I am talking about, I plus j whole square. I1 j1. So 1 plus 1 whole square by 2. So 2 square by 2, that is 4 by 2 is 2. This is the first element. Same way we will write the other elements. What is A12? Next element. A12 equal to 1 plus 2, j is 2 now, whole square by 2. So 3 square, 1 plus 2, 3, 3 whole square, 9, 9 by 2. Like this, we can write the other elements also. What is the next one? A21. A21 is same because, okay, next A21 equal to 2 plus 1 whole square by definition by 2. So again 9 by 2. Last one A22. So A22 means j is 2, I is 2. Both are 2. So 2 plus 2 whole square by 2. So 4 whole square 16 by 2 8. Now same way you can fill the other two. Aij is I by j. Second problem is direct. So what is now first one I will complete. Yeah, so what is A then? Therefore A equal to, fill all this. A equal to first problem, completing the first problem. A equal to A11 is 2, 9 by 2, 9 by 2, 8. 2, first one, next 9 by 2, next one 9 by 2, 8. This is a matrix A. Formed from the definition Aij equal to I plus j whole square by 2.